Assalamualaikum and good day. Today, we are from Group 11. We'll be going to present our programming project entitled Engineering Beam Design Analyzer. Before that, let me introduce our great team. I am Afiq Azmansah, and alongside with me are Abdullah Hafeez, Nabil Haqeem, Haziq Rashidi, and Hasif Hairuddin.
We will start with the introduction. This project aims to develop an analyzer to determine the most suitable design of beams to support different types of loads subjected vertically on the beam. Now, the reason why beam design is very important is firstly because of support. A beam is used to support the weight of a building's floor, ceiling, and roofs. Other than that, stability. Beams need to be braced properly along their sides so that they do not move sideways or suddenly become unstable. And lastly, it is to resist deflection. The load that is applied on the beam must not exceed allowable shear and bending stresses. Now on to the objectives of the project. First of all, it is used to ease the users in determining the most suitable design of beams in supporting different types of loads subjected vertically on the beam. Second, it is used to collect and gather the data of beam designs and problems from the users for future reference.
So right now I'll be showing the demonstration of our program. So this is the interface for the main menu. So let's go enter number 1. So it will go to the add beam function. So we'll just try it. Okay, just try enter the beam name. Let's say it is Ahmad, and it will prompt us to insert the beam type. It show us the options, which is whether it is a cantilever beam or cantilever simply supported beam or simply supported beam, or whether it is fixed ended beam. So let's say it is a cantilever beam. So let's enter the beam length. Let's say it is 11 meter and the W shape of it. So let's say it is maybe 460, 60. So then it will prompt us for the allowable bending shear stress. So let's say it is 200 megapascal, and then allowable shear stress, let's say 100 megapascal, and after that it will say the load type, whether it is point load or uniformly distributed load. So let's say it is a point load. So load from us enter the distance of point load 1. Distance is measured from left side of the beam in meter. So let's say it is 1, and then it prompts us to enter the force for point load 1 in kilonewton. So let's say it is 3.1 kilonewton, and then for the next one, it prompt us to enter the distance of point load 2. So let's say it is 40, and then it is error because it is an invalid input. It is much higher than the beam length. So let's say we put it as 8 meter, and we enter the force for like let's say 25 kilonewton, 35 kilonewton. So it prompts us to whether or not we want to enter more another beam or no. So I don't want enter another beam. So let's say we enter 0. So it will get back us into the main menu interface. So let's view the beam. We enter the 2. So this is the inter beam that I have entered the beam before to save our time for the demonstration. I just enter 1, which is Ahmad just now. So yeah, we can see that Ahmad is in there in the test file. So we can see all the beam here, and Also, we can see what is the beam number, name of the beam, type of the beam, designation W shape of the beam, allowable bending stress of the beam, allowable shear stress of the beam, and type of load exerted on the beam. So let's press any key to get back into the main menu. So for the third option, it is a search beam. So let's go into it. So for the search beam option, we can put any number that we want from our entered beam before. So let's say we want to view the fifth beam that we entered before. So let's go for the 5. So this will show us the fifth beam that we entered before. So next, the programmer from us, do you want to search another beam? So let's see whether it is right or wrong for the fifth beam. So let's take a note on like 3 of it. Cantilever simply supported 12 W6 610 times 125. So let's get back to it and let's go to the view. So let's go to the fifth beam. So it say that the fifth beam is cantilever simply supported W610 times 125. So it is true at what we searched before. So let's proceed to the fourth option, which is modify beam. So let's go for the modify beam. So it will prompt us select beam to be modified. So let's say I want to modify the 10th beam that we just entered just now. So select the aspect of the beam to be modified. Let's say we want to change the allowable shear stress. So let's go for 6. And the new allowable shear stress will be, let's say, 150 megapascal. So do you want to modify any aspect or beam? So we'll go for no right now. So let's view it. So allowable shear stress of the beam, which is 6 on the 10th beam, has changed to 150 megapascal. Okay. So that's for modified beam. So let's go for the next option, which is delete beam. So delete beam, it will enter which beam to delete. So let's say we want to delete the 10th beam that we entered just now. So it said that beam 10 is successfully deleted. Do you want to delete more beams? So right now it's just no. Okay, so for the 6th, let's view first the beam. Is it deleted? Yes, it is deleted. Okay, so for the next one, we'll review the appendix B. So this is the appendix B. This what is in here is stated here, and yep, this is the appendix B that from the textbook. So let's get into the business for the 7th option, which is calculate beam. So we go to enter the 7th option. So select beam to calculate its specification. So let's go for the first option. So support ration, so it is automatically calculated. It will show us the support ration at fixed end, which is 35 kilonewton, mass bending, which is 94.5 kilonewton meter, mass shear is 35 kilonewton, and as required is 630 times 10 to the power of 3 millimeter cube, and average shear stress is 11.6 megapascal. So after that, it will prompt us, do you want to calculate another beam? So I don't wanna, but for you, let's go for yes. So it will go to the interface before. So let's go for the second beam. So it will show us like before, but it is for the second beam. So you can read it. So after that, do you want to calculate the beam? So let's go to no. So let's move on to the find the best beam, which is the 8th option. So 8th option is, do you want to find the best beam among all stored beams? If we want to find the best beam among all stored beams, so we go for 1. If no, we want to compare the specific beam, or like we want to compare 1 or 2, 1 with 2, or 9, 8, 7, we can go for the option 0. So right now we go for 1, and for the by comparing all the beams, the systems calculated and concluded that the best beam is the beam number 5. So the beam number 5 is the best option, the best beam. So do you want to find the best beam again? So enter 1 for yes, or enter 0 for no. So let's go for the specific beam that we want to enter. So let's go for 0, no compare specific beams. So enter the number of beams for comparison. So let's go for, like, we want to compare 2 and 4. 2, 4, 6, let's say. 2, and then, oh no, this is the number of beam. The number that we entered just now is the number of beams that we want to compare. And for the first beam, which is we want to enter right now, it is, like, we can say 2, and we say 5. No, 4. So the program concluded that the best beam between 2 and 4 is, the best beam is 2 in here, which is 4. The fourth beam that we entered, it will be second beam in here. So do you want to find the best beam again? So let's go to the main menu. So finally, the last option is exit program. So if you enter the exit program, it will exit the program. So that's all for the demonstration of our program. Thank you.
So now let's move on to the modules of the project. Module 1 is the main menu. The main menu will give the option to the user to choose the desired operation. There are 10 desired operations, which are: first, add beam; second, view beam; third, search beam; fourth, modify beam; fifth, delete beam; sixth, view appendix B; 7, calculate beam; 8, find the best beam; and 0 to exit the program. In the add beam function, the user will be able to add the desired attributes of the beam and the type of load acting on the beam. The user can enter the beam name, the beam type, beam length, W shape, allowable bending and shear stress, and the load type. Then, the user will enter the distance of point load which acts from the left side of the beam. In this function, the user can view the beam entered. The characteristics of the beam will be displayed in an organized table like shown below. In the search beam function, the user can search the beam by entering the number of the beam. The beam will be displayed as shown below. In the modify beam function, user will be able to modify the attributes of the beam if they worried they might enter it wrongly. The user can modify the beam name, the beam type, beam length, W-shape designation, allowable bending stress, allowable shear stress, and also the load type acting on the beam. In this delete beam function, user can delete the beam entered, and the beam will be removed from the text file.
Appendix B is the table that shows the variation section number of wide flange I-beams, and each of section number has its own web thickness, flange width, and SXX. In this particular function, user will be able to view this table as a reference. All the values produced by the program follow accordingly to the designated Appendix B. Therefore, this function can be considered a success. In calculation function, all the formula for each type of beam and load will be tested. Basically, the purpose of this function is to calculate the support reaction at both ends of the beam, AY and BY, maximum shear, Vmax, maximum moment, Mmax, section modulus as required, shear stress, tau average, and eventually to compare the S required with S beam and compare tau average with tau allowable in order to determine whether the beam passed the requirement or not. The beam is only inserted if the S beam is greater than S required and the tau allowable is greater than tau average. This function can be considered a success as all the calculations generated by the program are similar to the manual calculation, indicated by the green color. In this function, the user can find the best beam among all the accepted beam available in the entered list. In order to find the best beam, the difference between S required with S beam and tau shear with tau allowable will be found first. Then, the difference between both will be summed up. The best beam will be identified through the highest value of summation among all. This function can be considered a success as the best beam generated by the program is similar to the manual calculation, indicated by the green color, which is beam number 5 named Hafeez.
Now, let's look at the specialty of this program. The first one is application of solid mechanics. There are two functions that involve the application of our past course, solid mechanics. In our program, we are making a beam analyzer, which takes some requirements into consideration to choose the best beam that can support a structure successfully. The two functions are calculate beam function and find the best beam function. Next, the program is intuitive and easy to use for users. We have made the navigation between all the functions as efficient as possible. Users can choose to go to any function from the main menu. After making an action in a function, they have the option to repeat the action or not. They can also go back to the main menu after selecting a function if they want to use another function. Other than being functional, this program also has detailed error checking. This is to ensure no error from user input. To avoid interrupted use in our program and possible logic errors, the program will make sure that the input from the user is correct. It will tell the user if the input is incorrect by showing invalid input. Then, it will ask another input from the user. So what about the limitation of this program? One of the limitations of this program is users that do not understand the process of designing and calculating a beam may struggle to use the program. There is no pictures and graphics to ease the process of designing a beam. For those who understand, they will find this program helpful and time-saving when analyzing beams. Other than that, this program can only calculate limited number of loads within a limited range of beam type. In the real world, there are many ways a beam can be designed. There could be multiple loads and other types of beams. However, time, programming language, and knowledge constraints have created a limit to what this program is able to do. Lastly, error checking is made as detailed as possible, but with one significant limitation. It cannot deal with the error when a user inputs an alphabet while the program is asking for an integer. A function has been designed to cope with this problem. However, due to time constraints, the function is not included.
Throughout the project, we communicated a lot to solve the different issues we were facing. We also discussed to make sure that the program was working the way we want it to work and it was working without any problems. For future improvement, we should do meetings more regularly so that progress is constantly being made. Now, we are proud to create this program because it is an original idea by us in reference to other sources on the internet. Now, because of this, for future improvement, we should continue to learn the different programming languages out there because it is an essential skill, especially in this era. Now, in conclusion, this project is a success and we have achieved the objectives of this project, which is to use the users in determining the most suitable design of beams in supporting different type of loads subjected vertically on the beam, and also to collect and gather the data of beam designs and problems from the users for future reference. Thank you.